Hello, this is James Fisher, and we are continuing our lessons on the mole, and now we are going to connect it into the realm of atoms and the atomic structure. Um, as clear as you can see here, we have a hydrogen atom, and the only reason it has one plus is because hydrogen has no neutrons, so I only drew one proton there, as you can see by the plus sign, which is the standard for talking about protons or neutrons or different particles. And we have the electron spinning over here. Now, I just wanted to put as a side note, there are certain ways that we can draw electrons. So if you see me in later videos drawing electrons in certain ways when we do subshells or principal quantum energy numbers and stuff like that, or things of that nature, we will be using certain ways to draw the electron. You could draw the electron as half arrows, or you could draw it as a beta particle. Now, I don't like people drawing it as a beta particle because these are two different particles. And when you learn in nuclear chemistry, you'll understand this difference. But for note-taking purposes, you can write it as a beta particle if you want to. So basically, go a little up here. So basically, Amadeus Avogadro, he constructed a universal constant of atoms, and he made a universal unit constructing the mole. And he basically stated that the mole is equivalent to 6.02 times 10 to the 23rd atoms. And it's amazing because a lot of people get this confused. They think that molecules, atoms, and moles are all the same thing, and indeed they are not. It takes a lot of atoms to go into one mole, but the mole is much bigger than the atom. And that's where a lot of times people get confused. And it really depends on the question, because if the question asks you for atoms, you give them atoms. If the question asks for moles, you give them moles. So to explain this a little bit, I wanted to compose a problem. And the problem says, convert 0.5 moles of a compound containing hydrogen into atoms. And this is basic algebra. If you're looking for atoms, you need some way to cancel out the conversion of moles. And I'm going to explain that in a minute. If we have 0.5 moles, and that is given to us, we're going to need to convert. So we need to multiply by the standard 1 mole, because we're trying to solve for atoms. So we need to know how many atoms go in 1 mole. Then we can multiply, divided by 1 mole. So we have 6.02 atoms on the top, because that's what we're looking for. And I put per mole because a lot of times in chemistry we cancel out units to get one basic unit, and this is called dimensional analysis, and it's also called unit analysis. So if you see me a lot of times dividing by 1 unit, I'm just trying to cancel out units using algebra to make it more understandable. So we're going to be left with 0.5, which is a number all on its own. And we're going to multiply it by the atoms in a mole, which is 6.02 times 10 to the 23rd atoms. And whatever we get as our answer will be our answer in atoms. So it's basic algebra. It's really simple. There's really nothing much to it. You just have to understand conversions, and you have to understand proportionalities. If I have 6.02 times 10 to the 23rd atoms per 1 mole, obviously you're going to have less atoms if you are multiplying by half a mole. So just something to think about as we go on into our next lesson on molarity, concentration, and titration, using mole or using the mole as a general perspective, or we're going to see it from the mole's point of view. So that's pretty much it. That's pretty much it. So next video we're gonna talk about that a little bit. Hopefully you can understand this concept and master it for the next lesson. Okay, bye.